All right, so welcome back. So I hope that now you have all your energy before we dive into scary XML. All right, XML means extensible markup language. It looks like HTML for those of you who know HTML. It's actually a cousin of HTML. It's sometimes called the tag soup because in XML, you basically tag text, you add tags. And the tags look like what you see on the screen right here using these angle brackets. So we saw the square brackets for JSON arrays, we saw the curly brackets for JSON objects, and we have the angle brackets that are for XML elements. So this is the first building block. I'm going to use the same approach as for JSON. In JSON, I told you about strings, numbers, booleans, nulls, objects, arrays, 6 of them. I'm going to do the same with XML. I'm going to give you the building blocks, and then it's like a Lego game. You assemble them. So an element has a start and has an end. It's basically tagging a portion of text. This here is the opening tag. This here is the closing tag. How do you see the difference? Well, first you have these angle brackets around the tags, but here you don't have a slash. Here you have a slash. Right? It's like when you leave a city with your car and you have the slash that says it's the end of the city or of the village, right? So this is the end. So this is a region basically that is surrounded by this opening tag and this closing tag. And here in the middle, you just have more XML recursively. Just like in JSON, you can nest arbitrary values. Here you can nest arbitrary XML. Now, we computer scientists are lazy, and I'm not the last one. So we love to save space. And in the case that there is nothing inside, so you just open the tag, close the tag, we have a shortcut for that. That's called an empty tag. That is right here, an equivalent to this. The difference is that the slash is at the end. So if the slash is at the end, it's basically both opening and closing, but there is nothing in there. Do not confuse the closing tag and the empty tag, right? So this is an element. The next building block of XML is the attributes. The attributes are also based on key value pairs. We have key value pairs everywhere, right? So this is again the key value pair model. Within an opening tag of an element, within an opening tag, you can have key values. In that case, we have at, which is the key, and value, that is the value. The key is not quoted, right? Just appears just like the element name is also not quoted. So the attribute name is also not quoted, right? So no quotes here, no quotes there. The values, however, are quoted, single quotes or double quotes, even if it's an integer and so on. We'll see actually that XML doesn't even know about integers in the syntax. So there's always single or double quotes right here. This is not like JSON, where you could have unquoted integers, booleans, nulls, and so on. Now, that might be a bit of getting used to for those of you who are used to HTML, because in HTML, you have some tolerance for unquoted attribute values, but not in XML. In XML, we require the values of attributes to be quoted, all right? It can be in an opening tag, but also in an empty tag. Right? So this is why in that case, it's actually an empty tag because you see the slash that is at the end. So this is an empty element, but it has an attribute with a value, right? So you can have an attribute in here, you can have an attribute in there, but never here, never in a closing tag, all right? Okay, let's move on to the next one then. Text. Well, this is basically like strings in JSON, but again, it's not quoted. There is no quotes anywhere. Just put the text between an opening and a closing tag, and that's pretty much it, right? It's not very complicated, actually, XML, right? But it's because I removed everything that's complicated for you. So this is text, and you also have comments that look like this, also with angle brackets and an exclamation mark and a double dash. And at the end, also a double dash and a closing comments. Now, several things about that. First, why on earth does a comment look so complicated? It's history. Technically, what actually happened is that there was a markup language called SGML. can you believe it? It was even more complex than XML in wide use in the publishing industry. The publishing industry is one of the biggest consumers of HTML, XML, and so on. So you basically store scientific papers, documents, books, and so on in this kind of format. It's very natural because look how easy it is to put text in XML. This is why it's so popular with the publishing industry. Then you can tag the text. You can say, this is a header, this is bold, this is italic, and so on and so on. Right. Okay. And the reason why it's so complex here is that XML was born, and really that's not a joke because I'm pretty sure that it's not a joke. XML was born as a simplification of HTML, right? So we took HTML, it was so big, and we just eliminated a lot of the complex things, and XML is the part that survived, and that was then standardized. So these things here with exclamation mark, blah, 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 is just some survival of these HTML times that you see some remnants of these here and there. So the main reason is scary is really that, because if you ask yourself, why does it look like this? There is no real reason except that it's related to the way that HTML was developed, and it was just kept in that way. So you just need to learn it by heart, basically. Now there is also this, which is also a remnant of HTML. It's the text declaration. But don't be scared, because this is really just what you see on the first line of an XML file to declare it as XML. That's really all it is. So in that case, you say, okay, that's XML, it's version 1.0, and the encoding is UTF-8, right? By the way, again, a reminder, you should really avoid encodings that are not Unicode-based. So of course, there's UTF-16, UTF-32 as well, but you really should make sure that you internationalize anything you create, right? So UTF-8 is a good idea. What about the version? Don't worry too much about the version. There's two versions of XML, 1.0, 1.1. There's almost no difference between the two. The differences were really, I think, mostly focused on changing the model of what is allowed and what is not allowed. Basically, in XML 1.0, anything that, let me get this right. In XML 1.0, everything that was not explicitly permitted was forbidden implicitly. In XML 1.1 is the opposite. Anything that is not explicitly forbidden is permitted, right? So there's a bit of switch in the mindset, and some other details such as allowing more international characters in the names of the elements. But for all practical purposes, you really don't need to worry too much, and this is why actually XML 1.0 is still in very wide use. Right. Okay, so that's actually it. Elements, attributes, text, comments, and the text declaration. There's actually more. It's just that I just took it out because I think you don't need that in order to understand data sets, right? So we'll focus on just these building blocks. This here, what you see on your screen, it has the green tick on the right. This is a well-formed XML document. So you see on the first line, there is just this declaration that is XML, right? XML version 1.0, UTF-8. Note that it is optional. You don't need to have it, but you can. And here what I have is an element. Is it closing, opening, or empty? It's empty. This is an empty element, so there's nothing inside. That's called foo. This is a well-formed XML document. This is also a well-formed XML document because, as I told you, the text declaration at the beginning is not mandatory. So this is also a well-formed XML document. In fact, the shortest XML document you can possibly imagine has 4 characters. It's basically angle brackets, some letter, slash, and closing angle brackets. That's pretty much the shortest you can have. Why is that not well-formed? Yes, go ahead. Maybe the microphone. If Yes, exactly. We have 2 elements. I'm not sure if the microphone was actually working. Could you hear over the loudspeakers?
What? Hello?
Oh, now it works. Yeah. So indeed, you are correct. you have two elements in there at the top level. This is forbidden in a well-formed XML document. You cannot have that. This, in fact, would be called an XML fragment. It means it can appear in the middle of an XML document, but not as the whole XML document. So here, not well-formed. This is well-formed. What happens? We have an element foo, which is opened here and closed there. And inside it, I told you, you can put more XML, and this is a nested element called bar, and in that case, it's empty, right? So you see, we have nestedness here. It's just like in JSON. You can have an object in an array and so on. Here you have an element inside an element. This is well-formed. This is not well-formed. Why? Yes, exactly. We have text outside of the top level elements, and we cannot have that. The text must be inside, right? So this is well formed. Look, something interesting is happening in there. That's very heterogeneous. We are mixing things. Look what happens. We have this foo opening and closing, and in the middle, what do we have? We have text, then we have an element nested, and then we have text again, right? So this is absolutely fine, but this is not fine. You cannot have free floating text outside of the top level elements. This is not allowed. Why? This is not well formed. Maybe we can give the microphone. I hope it works. Yeah, we are not throwing it like we do with the catch box, unfortunately. I will repeat, don't worry. Exactly. The attributes here, what you have is the attributes inside foo, but it's not an attribute that you see here. So that doesn't work. You cannot put an element inside a tag, inside an opening tag. That's not correct. What you would have here is attributes. So you're absolutely correct. You can only have elements between tags, right? In the middle, but not inside the tag, right? This here is well formed. Okay. This is also not well formed. Can anybody see why? I'm just going to reassure you, the reason it's not well formed doesn't make any sense, at least to me, and that's just, again, a remnant of SGML. But there is a reason why this is not well formed. Yes? Exactly. With triangle shape, you mean the angle bracket, right? Exactly. So indeed, that's exactly correct. You cannot have, inside an attribute value, you cannot have an opening angle bracket. And again, here, as a computer scientist, you can be like, but why? You could absolutely write a parser that is able to parse this, right? Because you know it's an attribute value and so on. But in fact, I guess one of the motivations is if you disallow this, you make it much easier to implement a parser because you're making the angle bracket special. And that means that the parser can very easily recognize where the tags actually start because it knows for sure that if it sees an angle bracket, it's a starting tag. So that's probably the reason, right? And this is fine. Of course, we need to escape them and show you how to escape them. This is fine, okay? Something else, it's secondary, this thing here, but you might have seen it as doctype. Who saw doctype HTML already? Right, so we have this in here as well. We can have a doctype declaration. This is basically the same, it has to be the same name. So what you see here, document must be the same as the top level. It's just a declaration that this is an XML document and that the top level element is called document, right? This is also for historical reasons. Typically what we have in the doctype is called Dtd validation, but Dtd validation today is losing in usage because it's too old and becoming obsolete because now we have XML schema. So this is why I don't even teach DTDs anymore. I used to in the lecture, but I completely dropped them from the lecture material. So you don't have to worry about the DTDs, right? But if you see doctype, then you know that this just is a declaration of the top level elements. Okay, this is a summary table of what appears where. So let's look in details. We are saying that at the top level, we must have exactly one element at the top level. we cannot have attributes in the wild. Attributes cannot be anywhere outside a tag. So we cannot have top-level attributes. We can also not have top-level text. The text must be within the tags of an element. Okay, so this is top-level. Exactly one top-level element. Between element tags, you can have nested elements, as many as you want. You can even repeat them. It doesn't matter if you repeat several times elements with the same names. In fact, we do it all the time in XML. You cannot have attributes between element tags. We said they must be in the tags, so they cannot be between the tags. So no here. And text can absolutely be between element tags. Okay. And finally, third column right there says that inside the opening element tag and also the empty one that is kind of similar, you cannot have nested elements, not in the tag, but you can have attributes inside the opening tag and no text inside the tag, only attributes. Okay. It's very important, maybe one of the areas of confusion, do not confuse the notion of an element and the notion of a tag. An element is a building block of XML. It is syntactically made of tags, right? An element has an opening tag and a closing tag, or it has an empty tag, right? But the tag is syntactic. The element, as we will see later, has a semantic. It's part of the model of XML. Okay, for whom is that clear? Okay. Now I'll do the same with JSON and show you a few corner cases and how we fix a few issues like escaping. So why is this not well formed? Yes? Exactly, the attributes names must be unique. Here we have twice the same attributes, right? So this is not allowed. This here is fine. We have two attributes, but they have different names. So this is fine. And here it's not a should. It's not like in JSON. In XML, it's an absolute no-go. You cannot have repeating attribute names, right? What's the problem with this one? Yes, go ahead.
The inner elements need to be closed first before the outer ones
Exactly.
can be closed. You
need to first close the last open elements, is the way of putting that. It's basically LIFO, right? It's not exactly that, but you could think of it as well parenthesized expressions, right? You cannot do whatever you want. So here we basically we open A and we open B and we close A first. That doesn't work because if you look at what's inside A, there's just an opening tag with no matching closing tag. I should show here. We have here an opening tag for A and a closing tag for A. We need to look at what's in between. This in between is not well-formed XML because that's just a standalone opening tag with no matching closing tag, right? It would be there, but this you cannot do. You cannot do it later. So this is not okay. But here, you see it's nicely nested. We have A and B is within A, right? So it's well parenthesized, so to say. For whom is that clear? All right, yes? Let me see if I figure it out again, because this is a thought that I had and then I realized it's not exactly like well parenthesized. Well parenthesized is based on a binary. You open or you close the parentheses. In the case of tags, you also have the names. Here, you could argue if you don't look at the names of the elements, it is well parenthesized. You open, you close, you close. So the problem here is the names. It's the order in which you close, right? So it. Yes, absolutely. If you give colors to the parentheses, then yes, absolutely. Yeah. Okay. Okay. What's the problem here on the top? Yes. Exactly. The parser would be confused because normally the angle brackets open tags, but here it's not a tag. We really mean lower than, one lower than two. Of course, in HTML, you're going to tell me, okay, yes, but there is the script tag with JavaScript, and we can actually do that in HTML and so on. But again, HTML is more lenient, and in XCML, we just disallow that completely. All right. So what do we do about it? Well, we escape. but we are not going to escape with backslashes and, you know, in the way that we did it with JSON on other languages. We actually escape like this. That might be confusing, but actually it's not, because this LT means lower than. This is a lower than sign, right? So LT, lower than. Escaping is done in XML with an ampersand and a semicolon, right? So we escape with ampersand LT semicolon. I have good news for you. There are only 5 escape sequences in XML. They correspond to basically the common things you need to escape. So we have lower than, we have greater than, GT. We have the apostrophe, the single quote. We have the double quotes, that's called quotes, and we have the ampersand with AMP, because whenever you have an escaping character, you need to be able to escape the escaping character. It's like the backslash, right? So if you need to escape the ampersand, it's AMP. So as you can imagine, that's basically coming back to your question about CSV. In CSV, you would double the quote. In XML, what we do is that we escape with what I showed you here. So we need to look up how do we escape the double quotes. We escape it with this quote. So here you just need to fix this thing, which is incorrect. You need to fix it by escaping as ampersand quote semicolon and ampersand quote semicolon. Now you're good. Okay. The same here, you cannot have, this is the problem we had earlier, that we have this angle bracket sign in the middle of an attribute value. That's not okay. And we fix it by looking it up. This here is LT. So we fix it by replacing with ampersand LT. What's very important to understand, sorry, is the same as is in a JSON string or in a string in Java, is that if you escape a character, on the logical level, it's the actual character that appears. So if you have ampersand LT semicolon, in the syntax, you will see ampersand LT semicolon. But once you have loaded that in memory with your parsing library and so on, in the memory, you will actually see the smaller than character if you just print the string value of the attributes. Do we have questions?
Yeah, there's one online. Can you use apostrophes inside quotes and the other way around without escaping them?
Single in double and double in single? Yes, absolutely. And I have an example right there. So I'm super happy you asked the question. Let me start and then I'll come to you. Okay, then I'll answer the other question. Okay, so what to escape where? I added a summary for you. In text, you have to escape lower than and ampersand. In attributes, you also have to escape lower than and ampersand everywhere. But the addition in attributes is that in double quoted attributes, you need to escape the double quote. In single quoted attribute, you need to escape the single quote. Look at this here. This is a well-formed, let me move that thing around. Of course, it doesn't disturb you on Zoom, but in the lecture hall, that was hiding it. So you see, I have here a double quoted attribute. So it's totally fine to have an apostrophe and a greater than, but I have to escape the double quote, the angle bracket lower than and the ampersand. Here I have a single quoted attribute that ends there. So I'm totally fine writing double quote and greater than. I have to escape the apostrophe, lower than and ampersand. And in text, I can absolutely have greater than, this is fine, double or single quotes, and I have to escape lower than and ampersand. Is that clear? Does it answer your question on Zoom? And here it's guaranteed to be well-formed because I actually put it in Oxygen, which is a software we will use, and Oxygen told me that's well-formed. So I actually double-checked because that's complex. I wanted to get it right. Do you have another question? Oh, was it answered? Awesome, perfect. By the way, I wanted to tell you an anecdote about ampersand, an anecdote that I like. Do you know where ampersand comes from? So it used to be a character in the alphabet, in the English alphabet. We now have 26 letters, right, in the English alphabet, but we had more. Some of them actually are still in Icelandic, in the Icelandic language, right? So they disappeared from the English language. But the last additional character that disappeared from the English language is the ampersand. And it was at the end, after the Z. You know what this symbol means? It means end, right? It's actually used in programming languages as the bitwise end, and also when you have the end logical operator, right? So it means end. In fact, if you look closer, it's from the French et, ET, which means end. And it's just an E and a T that are kind of with a work of art on top of that are merged together. But basically it means end, and that was read as end. But imagine reciting the alphabet at school, right? You are in a classroom and you ask the children to recite the alphabet, and they go all the way A, B, C, blah, 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 X, Y, Z, end. That sounds weird, right? You end with end, X, Y, Z, end. And so what they did in order to make it nicer in the classroom, they say, we say X, Y, Z, end per se, end, which means end all by itself, end, right? End per se, end. Now say it faster, X, Y, Z, ampersand, ampersand. That's exactly how this ampersand word actually was born. That's the history of why it's called that way. Okay, who learns that? Who didn't know about that? All right, and you can find classroom textbooks from the 19th century that have this ampersand sign at the end of the alphabet. Okay, now, you cannot do anything you want with XML names, but that shouldn't really surprise you as computer scientists, because you also know that in Java or Python, you cannot call a variable whatever you want, right? You cannot call a variable plus, for example. It's the same here. You cannot start an XML name with a digit. It's exactly in the same way that in Java or Python, you cannot start a variable name with a digit, right? It can be after, you know, as part of the name, but not the first character. We already saw, you know, the angle brackets can also not be part of the name. It's totally fine to have digits in the middle. The underscore, just like in Java, actually, or C++, you can start with an underscore. Do we have a question?
Yeah, so why do we need a special character for the angle brackets if we don't need to escape it?
Where do you refer to? Just trying to find the slides that you special character. Oh, I see. I see. That's actually a very good question, because if you don't really need, why do you? I think it's probably for completeness. Maybe also for cosmetic, if you want to escape. For example, what's very common is to escape HTML inside feeds. You know that the feeds are like Atom. It's in XML. So you have a feed in XML. And what you typically do is that you put escaped HTML inside as text. If you escape the lower than and not the greater than, it doesn't look very nice. So it can be less confusing if you also escape the greater than. But I know that this is not really a satisfying answer, right? Because why do we care about cosmetics for something that a computer reads? But I really think I don't have a better answer. I really don't know. I think it's probably just that there was a discussion on what symbols do we need, and they decided it's these 5 that should be escaped. I'll still try, actually, that's the first one that somebody asks that. So maybe we'll try to investigate and see if we find something. Okay, but that's a very good observation, because if you want to be minimalistic, then you're absolutely right that we could just do with 4 instead of 5 characters. Okay.
There's a question here.
Yes?
I don't understand why we prohibit 1, 2, 3, 4. So in Java, we do it because we treat integers differently, but we have to quote everything here anyways, right?
Yes,
so we
this
could
is
treat
correct.
them
You
as
could
just
argue,
characters.
Yeah, you are correct. What you're saying is essentially it would not be impossible to allow for the digits here and build a parser that is able to process that. I think it's also because of the whole tooling ecosystem that is around XML. For example, you map it to host languages, you know, as variable names or field names and so on. So I think it's just that they followed common practice here in terms of what is allowed. I think that would be my explanation.
Thank you.
All right. But there is a question that nobody asked on that slide. Don't you have any question on the third one? Okay, let me tell you, maybe you're wondering, but you just don't dare to ask. Why on earth do we forbid XML as a tag name? It's in fact not technically disallowed, because if you actually did that, the library would not complain. It's more that it's reserved. Anything that starts with XML, and it can be in any case, even lowercase x, uppercase m, and lowercase l, and so on, is strictly reserved for the World Wide Web Consortium and the working groups of the World Wide Web Consortium. It's basically just to allow the development of future technologies that might actually extend XML with special cased element names or attribute names. We'll actually see one today or tomorrow. So this is the reason why you cannot have it. But a question that appears every year is, yes, but why does Oxygen allow for it? It's just because Oxygen doesn't know the future, right? If in the future, the W3C decides to add something like that, it must be forward compatible with future XML documents. That's the reason. But you as users, except if one day you join the W3C in a working group, you are not allowed to do that, to use XML. So here I summarized what is allowed, what is not allowed. So everything that is in green or with the white characters right there is basically allowed anywhere. It's basically the letters and the underscore. Everything that is in blue and white characters is not as the first one, but within. So you can have colons, but we'll see they are special later, dash and period. Yes, you can have period. That's unlike in Java. And everything that is red or with the black characters right there is disallowed. You cannot have control characters, these special characters, and so on. All right? Okay. Next, you probably noticed that when I showed you JSON documents or even XML documents, I formatted them nicely. You know, like I put a closing tag on an opening tag on one line, then I nicely nest and indent the child tag, and then I again put on a new line the closing tag. This is also the case here, right? We have a nice indentation and so on and so on. This is actually known as the pretty print feature, right? That you have in many systems. The only reason we do that is that a human can actually easily understand. Who sees a tree here? Maybe more of you, right? Because there's the indentation and so on. In fact, it's because we can ignore that kind of white space, typically when we process XML as data, and that's the reason we typically do that. But you don't need to, you could put everything in one line, and that would be just as good. Okay. Who understands XML so far? Very good. So the goal is that you're fluent in parsing XML datasets. Now, if my voice allows me, I'm going to throw one more thing at you that is actually important. It is a bit more complex. It's namespaces. I'm going to introduce that by making an analogy that probably is going to make it easier. In Java, you have packages, right? When you write your code, you can put it in packages. So there is a hierarchy of packages. The same in C++. In C++, you have namespaces. So namespaces are basically there to put some order in the organization of your files, and it basically organizes everything nicely. So this is what namespaces are for. So they exist in XML. They don't exist or don't exist yet in JSON, because maybe a day will come that the JSON community realizes that namespaces can actually be useful, but we'll see. So this is why XML was extended with namespaces recently. And actually, they are almost part of XML now. We don't really distinguish. Here's the reason. You might have several data sets that you're using together that use names of elements, and now you want to join the two data sets. But what could happen is that your two data sets are using the same names for different things. Imagine you have a network data set and a customer relationship management data set. Client is not client. So here you have a problem, and the problem has to do with when you ensure, for example, and we will see in 2 weeks, we want to ensure a structure within clients. For example, the client on the left must, on the right must have a last name, first name, address, and so on. But the client on the left maybe will have an IP address, an operating system, and so on. But if they collide, it's hard to do that because you have an ambiguity in the two. That's exactly the same thing in Java. Imagine you have two classes with the same name. Well, you just put them in different packages, and that's fine. The packages disambiguate. In fact, that's exactly what namespaces do in SQL. on the high level. So the idea is that in addition to what we now will call the local name, that would have been the element name or the attribute name, we add a namespace. Now, namespaces in Java are basically dot separated strings. In C++, I haven't done C++ in such a long time. I vaguely remember a double colon, right? Something like that in C++. And now you might be wondering, why is there a URL, like the sort of things I would type in the browser, why is the URL right here appearing as a namespace? Do not be confused. The goal is not to type it in your browser and view a web page. It's basically due to the mindset of the W3C. Remember, in the REST API, a URL is here, a URI, or an IRI, if you want to be even more exact, identifies a resource. Any resource can have a URI to identify it. So since it's the W3C and it's a working group of the W3C, what is a namespace? It's stuff, it's a resource. So if we want to identify a namespace, why don't we use a URI as well? Right. But again, it doesn't need to be something you put in your browser. That's the reason why we use actually something that is a URI for the namespace. But you can view it as a black box, this URI. It's just some identifier for the namespace. So now, whenever we have an element name or an attribute name, we actually look at the expanded name. It's not different from Java. In Java, if you want to fully qualify a class, you need to put the entire package hierarchy dot the class name. That's the same thing. So this here would correspond in Java to all the, like inverted domain, you know, like com.java or ch.ethg, blah, 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 all the packages dot the name of the class. So this here is called the Clark notation, right? Where you have the curly braces around the URL and then the local name. That's again the equivalent in Java of the package followed by the class name to fully identify the name. So now you might think, okay, we've solved the problem. All we need to do is in our XML file, we just add the namespaces like this. You know, this is another example with a concrete example with a mathml namespace that actually exists. And it has tags for mathematical operations like EQ would be equal and so on. And so here you have expanded name mathml EQ. All right. So now you could think, okay, we could do XML that way, right? We just need to add the namespaces in the elements and we are done. But again, that's very verbose, it's complicated, plus we are lazy. So what do? This is what we do. We just use a shortcut. We say, okay, let's call it M as a shortcut. And yet let's use M everywhere in that namespace and just declare M as being this namespace. So what's going on here? This is the namespace in which I'm putting everything. That would be the equivalent of a package declaration in Java at the start of your document. Here, I'm using this XML. Wow, XML, I remember that special use for the working group. They said XML attributes are not really attributes. They are in fact namespace bindings. So this says that the M here is a proxy. It's a shortcut for this namespace. And now I can use M everywhere, followed by a colon, and then the name that would be the equivalent of the Java class, and here the shortcut for a Java package. All right, for whom is that clear? Right. So what happened here is we put an entire XML document in one namespace in that way. Okay. And just checking the time to make sure that I still have a few minutes, so I can show you that before you leave. It's just more details about what I said. We have here a special attribute that starts with XML. So it's not really an attribute. It's a namespace binding according to the standard. And it has different semantics, and these are the semantics. I'm really just repeating what I said, but just now with an animation. M is a prefix that is bound to the namespace http://w3.org 1998 mathml. That's a binding, and that means that M is used as a proxy, as a shortcut for the namespace. What really, really, really matters is the namespace. The shortcut is irrelevant. It's just whatever we do in order to nickname the namespace, kind of, right? And that means that we have in the document what are called in-scope namespace binding. It means the namespace bindings that apply to the document. And here it's basically a map from prefixes to namespaces. So what you do when you want to actually understand a document is that you look at the element name, you look for the colon if there is a colon. So here there is a colon, so it means whatever is on the left is a prefix, whatever is on the right is a local name. So M is a prefix, so I need to look it up in the binding. So I need to look in here and see that it's associated with this namespace. So that means that here, this element name is called the Q name for qualified name. The local name is math. The namespace is this, because this is what's associated with M. And the prefix is M. This is a Q name, and it's made of these three things right here. And just before you leave this last slide, and then I ask you if you followed, the prefix is irrelevant, and that means that this is exactly the same thing. Right. Only the local name and namespace really matter. The prefix is totally irrelevant. It's only really a syntactic thing to add as a proxy to the namespace. For whom is that clear? All right. So before you go, as usual, I'm checking that you followed. Oh, that's right here.
Actually, there's a question on Zoom. What's
I
the
answered that
local
question.
name?
Yeah.
What is the local name?
Oh, the local name, it's just the equivalent of a Java class name, basically. It's basically without the package, just the name without the namespace. I'll continue tomorrow, right? I can answer more questions. Okay. So the majority is above 80%. That's perfect. Some of them less. I'm not surprised. Again, XML is very scary, so don't worry. I can even take time tomorrow to answer. And anyway, in most of the class, the focus will be a lot on JSON, right? So don't worry too much. But you'll see that in fact, XML and JSON are the same thing. Thank you very much. See you tomorrow, 9 a.m. in the main building.